This is just a sample of the training available at itdvds.com. To see complete training, please go to itdvds.com. Let's begin the sample. On an Ethernet network, if we have two computers that are part of the same collision domain, try to transmit data at exactly the same time, a collision can occur. And when that happens, the data has to be retransmitted. For example, let's take our hub here. Let's say we have a computer plugged into port 1 and then another computer plugged into port 4. If the computer that's plugged into port 1 tries to transmit data, and by transmit data I mean the actual ones and zeros going across the Ethernet cable from the computer to our port 1 on our hub, if that happens and then exactly the same time the computer that's plugged into port 4 transmits data, those ones and zeros are actually going to run into each other because the ones and zeros are going into port 1 exactly the same time the ones and zeros are going into port 4. Remember, a hub is just a repeater. So it's going to try to repeat all those signals out all the different ports, and they're going to run into each other, and that's a collision. So then the hosts are going to have to retransmit that data because it's never going to get to its destination. And collisions are very bad. The actual effects of collisions are delay, low throughput, and network congestion. So basically, your network slows down. And hubs do not create new collision domains, so they don't break up collision domains. And this is why we don't use hubs anymore, because if we have a lot of hosts plugged into our hub, then there's a good chance we're going to have a lot of collisions, and those collisions are going to slow down our network. Now, a long time ago when we used to use hubs, we could use bridges to help with collision problem. Bridges actually do break up collision domains, but bridges normally only have a couple of ports. So we had to take one hub, connect that hub to the bridge, and then connect another hub to the bridge, and then we would have two collision domains, but that really didn't solve the problem. It just helped a little bit. And then along came switches. Switches really solved the problem because switches have as many ports as hubs, and they cost as much, or they can even be cheaper than hubs. Hubs are actually hard to find now. You almost can't even buy them because they're obsolete. So each port in the switch is a new collision domain. So let's take a look at a switch. Here we have our switch, and each one of these ports is a new collision domain. So let's say we have a computer plugged into this port, another computer plugged into this port, another one into this port, and so on and so forth. So let's say all the ports are filled up. Well, each computer is actually in its own collision domain. So you aren't going to have any collisions because in order to have a collision, two computers have to be in the same collision domain, and with a switch they aren't because one computer is connected to this port, another computer is connected to this port, so they're in different collision domains because each port is a different collision domain. Because of this, we could have all the ports filled up on this switch connected to many different computers, and we wouldn't have any collisions. All the hosts could actually transmit at the same time, and we still wouldn't have any collisions. So that's definitely not the case with a hub. We would have all sorts of collisions. It's also important to note that each port in our router is also a new collision domain. So it's not only switches and bridges that break up collision domains, it's routers as well. So let's take a very simple example here. We have two computers connected to a hub, and remember this symbol is a hub. How many collision domains do we have? Well, we only have one. That's because hubs do not break up collision domains. So if computer A tried to transmit at the same time as computer B, we'd probably have a collision. Now let's replace that hub with a switch. Now how many collision domains do we have? Well, we have two. This is a collision domain, and this is a collision domain because they're plugged into different ports on the switch, and each port on the switch is a new collision domain. So computer A could transmit at the same time as computer B, and we wouldn't have any collisions. Let's add a router. Now how many collision domains do we have? Well, we have three. 1, 2, and 3. Because each device here is plugged into a different port on the switch, and that makes each link its own collision domain. Now remember, routers do break up collision domains, but we only have one link here. So we don't have one collision domain for this port on the router and another collision domain for this port on the switch. It's just one link, so one collision domain. So again, 3 total collision domains in this example. Now let's take a little bit more advanced diagram here. How many collision domains do we have? Let's count them out. We have 1, this link going to this switch port, 2, this link going to this switch port, 3, the switch to the router, 4, router to router because routers do break up collision domains, 5, router to switch, 6, and 7. So 7 total collision domains. Now let's add a hub to our diagram we just looked at. So let's count out our collision domains. We have 1, 2, 3, because this hub is going to a switch port on the switch, so that makes it another collision domain. But these are not new collision domains because they're going to a hub, and hubs don't break up collision domains. So again, 1, 2, 3, 4, 5, router to router, 6, 7, and 8. So 8 total collision domains.